Assalamu alaikum and welcome to Aflak channel. We know that there are areas on earth where sometimes the sun does not set at all. We have a 24-hour sun, or the opposite where the sun does not rise at all. So first, how do we identify the times of the year and the locations where this happens? And second, how do we deal with these and calculate prayer times for? This is the fifth episode in the series explaining the equations for calculating prayer times. In the previous episodes, the prayer times for all prayers were calculated starting from Fajr to Dhuhr, Asr, Maghrib, Sunset, and Isha, in addition to sunrise time. All you need to do is specify the location, latitude, and longitude, then set the date, and prayer times will be calculated. If you haven't watched the previous episodes of this series, it's better to watch the series from the beginning. But note here that if we change the latitude to an area far north, at latitude 70 for example, and on certain days of the year, it's impossible to calculate some prayer times. And the same situation happens in the southern regions. In this episode, we will learn how to identify these special cases and how to implement one of the many ways to deal with these cases. And as we are used in this series, each episode will be available in two versions, one in Arabic and the other in English. This English version comes with English subtitles, and you can use YouTube automatic translation feature to choose subtitles in dozens of languages supported by YouTube. Let's begin. First, let's look at this diagram to understand the angle of sunlight on Earth. The blue circle represents the Earth, and the orange line represents the sunlight. And sunlight reaches the Earth at different angles. And we see that sunlight changes from north to south and vice versa throughout the year. And this angle is called the sun declination. And the main reason for this phenomena is the tilt of the Earth axis. We see that the maximum angle north or south is about 23.4 degrees. And the declination of the sun is not only at noontime, it's almost the same throughout the day, even at midnight when the sun is on the other side. Now let's add the observer, and this angle is the latitude of the observer location. This line is the horizon of the observer. We know that sunlight reaches the Earth almost parallel, and this angle is the highest point the sun reaches at noontime. And the sun declination angle applies even at night time. So on the other side, the blue angle represents the lowest point of the sun. And here, if we look at the angles, we'll see that some areas of the Earth experience days that the sun does not set, where the sun remains above the horizon even at midnight. And areas when the sun does not rise, the sun remains below the horizon even at noontime. There are also areas where the sun does set and rise, but it dips slightly below the horizon, and then reappears again, and the twilight of the sunset is mixed with the twilight of Fajr. So this means that the twilight of the sunset does not disappear for Isha prayer, and it does not appear after darkness for Fajr prayer. But how do we know when these phenomena happen? There are simple equations to calculate the highest and the lowest sun altitude. The maximum altitude of the sun is calculated using the equation 90 degrees minus the absolute value of latitude minus declination. And we use the absolute value because we don't care if the sun is towards the north or south. We can also calculate the minimum altitude of the sun throughout the day when the sun is on the opposite side, and we use the equation minus 90 degrees plus absolute value of latitude plus declination. We know that sometimes the highest altitude of the sun happens when the sun is below the horizon and the angle is less than zero, which means the sun never rises, resulting in continuous night. And there are situations where the lowest altitude of the sun is greater than zero, meaning the sun is always above the horizon and it never sets, and we have a 24-hour sun. And there are cases where the sun descends below the horizon at a very small angle. Now we learned how to calculate the maximum and the minimum altitudes of the sun based on the observer location and the sun declination. And in the previous episodes, we learned that except for Dhuhr prayer, the time for the rest of prayers is calculated based on the angle of the sun above or below the horizon. For example, to calculate Fajr prayer time, we determine an angle, let's say minus 18, And when the sun reaches that angle, we know that this is the time for Fajr prayer. But we see that there are cases where the sun never reaches this angle, and Fajr prayer time cannot be calculated. So to know if Fajr prayer time can be calculated, we need to compare the Fajr angle with the minimum altitude of the sun. In other situation, we can see also that the highest altitude of the sun is less than the Fajr angle, and it's not possible to calculate time for Fajr prayer. So for each prayer, we need to compare the required angle with the maximum and minimum angles. If we go back to the Excel file that we built in the previous episodes, and if you haven't watched them, it's better to follow this series from the beginning so you have the complete file. If we use a latitude in the north, we see that it's not possible to calculate Fajr prayer time because the sun does not reach the required angle. So first let's define MSA, or minimum sun altitude, and the equation is absolute value of latitude plus declination, we take it from the calc sheet, minus 90. And we call this cell MSA, minimum sun altitude. Here we'll put the maximum sun altitude angle, or XSA, and the equation is 90 minus the absolute value of latitude minus, we go to the calc sheet to take the declination. And we'll call this cell XSA, maximum sun altitude. Now we'll cut these cells and we will paste them here. In this row, we will put a value that determines whether the prayer represents a special case or not. Now, this is the Fajr angle that we use, and this angle must be between the lowest and the highest altitude of the sun. So in here, for Fajr prayer, we'll use the equation if and the angle is greater than the minimum and less than the maximum, then this is a normal case, we'll just put a blank. Otherwise, we'll put 1. So we know it's a special case. Now if we set the altitude to 86, we'll see that the Fajr prayer is a special case because the maximum altitude of the sun is approximately minus 19, which is less than the required Fajr angle of minus 18. And if we change the latitude to minus 50, for example, we see that the lowest altitude of the sun is approximately minus 17. Meaning it does not reach minus 18, which is the required angle for Fajr prayer. And if we change the latitude to minus 51, we'll see that even Isha prayer cannot be calculated. So in this cell, we'll put the equation if and Isha angle is greater than the minimum and Isha angle is less than the maximum, we'll put blank. Otherwise, we'll put 1, which means a special case. So if we set the latitude to 70, we'll see that the maximum altitude is negative, which means that the sun is below the horizon and it does not rise throughout the day. So we can apply the same rule for sunrise. If and the angle of the sunrise is greater than the minimum and it's less than the maximum, we'll just put blank. Otherwise, we'll put 1 as a special case. And the same rule for the sunset. If and the sunset angle is greater than the minimum and less than the maximum, we'll put blank. Otherwise, we'll put 1. Now we are left with Dhuhr and Asr prayer. Dhuhr prayer is never a special case. We can always calculate Dhuhr prayer time, and Asr prayer time is calculated using the shadow of the noon time. So first we need to calculate the shadow length at the lowest elevation of the sun as tan 90 minus maximum of minimum sun altitude, or 10 to the power minus 5, all multiplied by radian. We use the maximum here because there is no shadow when the sun is below the horizon. And we use a small angle of 10 to the power minus 5 because tan 90 is undefined. And the same way we calculate the shadow length at the maximum altitude, tan of 90 minus max of XSA, or 10 to the power minus 5, all multiplied by radian. And here this is the length of the Asr shadow required. So to determine if Asr time is a special case, we use the equation if the shadow of the minimum angle minus the shadow of the maximum angle is greater than the Asr shadow, we'll put a blank because it's a normal case. Otherwise, we'll put 1 to indicate it's a special case. But there is a note here. If we set the latitude to 67, for example, we see that Asr prayer time is a normal case. But we also know that the maximum altitude of the sun is approximately 0.04 degrees. And we know that noon prayer time is 12:24:20 and the Asr time is 12:25:29, which means there is a difference of 1 minute, which is not enough for Dhuhr time. So it's better to change the minimum altitude, and we add 1, and also change the maximum altitude and subtract 1. Now we have identified all the special cases, but how do we deal with them? There are several methods used, but one of the most commonly used methods is to use a latitude where the astronomical signs of prayer times do appear. So here we will define the alternative latitude, A-lat, and we'll use the value 45. But we note that we will use the latitude 45 for regions in the north. For regions in the south, we need to use negative 45. So here we'll put the angle and multiply it by the sign of the latitude. And we will name this A-lat for alternative latitude. Now we go to the calculation sheet. We'll copy this row and we'll paste it here. First, we need to take the angles, Fajr angle from the main sheet, then the sunrise angle, also from the main sheet, Maghrib angle, and finally Isha angle from the main sheet. We'll also need to do some changes. The length of the noon shadow, instead of using the latitude, we will use A-lat, the alternative latitude. Now we'll go through all the columns that calculate the angle in and change lat to A-lat. Also in the second column for Fajr, then N for sunrise and the second N, then 2 columns for sunset, change lat to A-lat, and finally for Isha, and here. Now, this row calculates prayer times using the alternative latitude. Now we'll go back to the main sheet and the time for Fajr prayer, and we'll change it to, if this cell is blank, meaning it's a normal case, we'll leave it as it is. Otherwise, we'll go to the calc sheet and take Fajr prayer time based on the alternative latitude. We will do the same for Isha prayer. If the time is not special, we'll use the time as it is. Otherwise, we'll use the time from the calc sheet based on the alternative latitude. But we note here that the sunset time is calculated according to the actual latitude because it's not a special case, while the Isha time is calculated using the alternative latitude. And because of this, the Isha time is before sunset, and this is not acceptable. So we need to treat sunset and Isha time together. We change the equation, and the condition is where both sunset and Isha are not special cases. We'll also do the same for sunset. If both sunset and Isha are not special cases, we'll leave it as it is. Otherwise, we'll use the value from the calc sheet using the alternative latitude. We'll change the title for this column to Maghrib because it's not sunset anymore. We'll also change the time for Asr prayer using the same condition. If it's a normal case, we'll leave it as it is. Otherwise, we'll take it from the calc sheet using the alternative latitude. And finally, the sunrise time. We'll see if it's a normal case, we'll leave it as it is. But if it's a special case, we will not use the alternative time because it's not a prayer time. We'll just put 3 dashes. And by that, we have finished determining the special cases and one of the ways to deal with them. And it's better to change the font color here to red. Now, anytime you change the latitude or the date, we'll see if there are special cases. And whenever we have special cases, we will use the time based on the alternative latitude. The next episode will explain how to calculate the direction of the Qibla wherever you are in the world, and also identify the times of the day where the sun is in the direction of the Qibla or opposite to it. I hope you find this episode useful. Please subscribe, enable notifications, and share this episode with those interested. Thank you very much and see you in the next episode.